So I was watching a video some days ago. It was by Big Clive. I like Big Clive. More YouTubers should be like him, in my opinion. Anyways, the video was about this test probe here, an inductive test probe, and as far as I can tell, this specific gadget is more for probing like small parts, small spots in very populated circuits like a laptop or a smartphone, because it doesn't seem to have a very high sensitivity, very broad, and it's very fine in the tip. But I'm not interested in fixing laptops or smartphones. I'm more interested in more sensitivity and possibly a proportional readout. So here's my solution. Okay, by my solution, I don't mean that I come up with the circuit by myself. I just copied it online. I typed on Google Images EMI detector circuit. There weren't many though. Anyways, this one was one of the first ones, and it was maybe the most convincing one. It was an old schematic also. And I just made a pair of adaptations on the schematic that I'll show you in a moment. And this one instead has a proportional readout. Yeah. And it's much more sensitive, that I really like. Okay, let's try this thing. Now it's powered. We have here an USB charger for a tablet, apparently. And through the charger doctor, it goes to a smartphone for simply charging it, no hacking here. And anyways, the thing is powered, and it already tells something. Maybe it's electrical noise. Anyways, let's power this thing and watch the needle and go. A bit of waiting. And it starts moving in max movements. Now the smartphone is charging and we have half 1 amp of current, and notice the distance. It also varies if I change the angulation of the charger, a bit more, a bit less. And if I get it closer, obviously it kinda maxes out. And those movements before were because of the smartphone, because apparently smartphones have to test the USB connection if it can go to max current or something like that. Anyways, let's put away the load and let's have just the charger. And now it's much less, obviously, because the duty cycle is lower and things like that. I don't know what kind of converter this is. There are some topologies anyways. But if I put it closer again, it again says something. And anyways, obviously we have to remember that these things are FCC approved and things, you know. And if you're wondering, no, simply mains doesn't trigger this thing, or almost at all. As you can see, it's powered. Sorry for this yellowed extension cord, but this thing is old as me. Okay, for the second test I have here a remote. This is a universal remote, and I don't recall that these things have inductors or transformers at all. Anyways, it lights up and it does something, especially on the LED, on the infrared LED. And the needle also vibrates because of the interleave between the pulses and things like that. Anyways, probably it's the infrared LED with high pulses of current, and the leads of the LED act as a single turn, probably a single solenoid turn, maybe. Okay, now I have a torch here with an LED, like modern, and if I turn it on at maximum brightness, it doesn't seem to do anything. But if I turn it off and turn it on again at a lower brightness, look at this. Why? What a mystery! An unsolvable mystery. Okay, now a smartphone, a regular smartphone, nothing special obviously. Let's activate it for having more activity on the sensor. Let's see. And it does something especially on the main board. Let's move it around. And it also has movements. less on the battery, obviously, and yeah. Okay, now a treat, look at this. This is some audio on the smartphone. Let's put it like this. Let's watch the needle. All'alba vincerò, vincerò, vincerò. Okay, now my multimeter here turned on, but it doesn't do much. If I get it very close, like this, there's maybe an oscillator with a crystal, probably. Nothing much. It's very, very silent. So this is the original schematic that I found online, and it's a very old metal can operational amplifier, metal can transistor. And anyways, as I said, I don't have to prove anything to anybody. So if I find a schematic that is already convincing, I do that. Anyways, about its age, this thing probably dates back to the 80s or even the freaking 70s. I don't know. Anyways, being this old, forget about that I mentioned the source of this schematic, because probably the actual developer died of old age. And these are the adaptations that I did to the schematic. Okay, first thing, I used a TL082 operational amplifier double, that in my opinion is more common than the single one, in my opinion. Anyways, I got these. And I disabled one of the two this way, that I suggest you. And anyways, this is exactly the same thing of the LF351 as specs. This is maybe more modern, I believe. Anyways, don't buy this component in China, because they will absolutely scam you with a bipolar one and not a JFET input one. But you can try with the BAT85 as diode in China. The BAT85 is a Schottky diode and there's a lower 4 volt voltage drop, so maybe the bottom range of the sensitivity improved. And the transistor now is a BC547, much more common. You have this. And for the instrument, I found that 100 microamperes is very good, positive here, negative here. This capacitor is smaller because we don't need lower frequencies, probably. And this resistor instead higher to be more gentle on the output of the operational amplifier, in my opinion. Also about that, I got rid of the headphones functionality because I don't need that, in my opinion. And also driving low impedance headphones with a wimpy operational amplifier, I don't think that's a good idea. Anyways, other mod is that the sensing inductor, in this case, has its ground really grounded instead of the middle voltage. This mod is maybe a bit worse in terms of noise because the input of the operational amplifier is not equalized in some way, but it's the same thing. And why? Because I have a coaxial cable for the inductor and I wanted its ground to be truly grounded and not in a middle voltage. But it's basically the same thing because there is this capacitor here. And the rest is the same because I trust this schematic. So for the sensing inductor, don't use closed ones like a toroidal one, an SMD one, a transformer-like one, or one that really looks closed, because these don't catch the magnetic field, and probably don't use like very small ones in line. These are impractical. For my project, I used a 1 millihenry one. These come probably from LED light bulbs. These are very easy to find. They range between like 1 millihenry to like 3 millihenries. Same thing at the end, maybe the more the better. Anyways, these inductors have a dumbbell-shaped ferrite core and it's open and very neat. So thank you for having watched my video and bye!